Hi everyone, I'm Brian Anderson from Team 3, and I will be starting off our term project presentation. Just a little overview of what we'll be going over today. We will be using the CRISP DM method to review our analysis. I will cover Step 1, business understanding, and Step 2, data understanding. My teammate Kelsey will cover data preparation. Sriraksha will be covering model building, and Don will finish us off with testing and evaluation and deployment. So without further ado, Step 1, business understanding. The purpose of the business understanding phase is to develop a roadmap for the ensuing data mining process. Typically, a goal is established in this phase to guide the analysis. With this project, we looked at the severity of injury that occur in automobile accidents. Automobile accidents seriously injure or kill thousands of people every year and incur billions of dollars worth of property damage in the United States alone. While it is not possible to fully eliminate the number of automobile crashes that occur, it doesn't mean that the severity of these crashes can't be reduced. In order to better understand what factors, if any, affect injury severity, our team conducted an analysis of the data sets from the crash report sampling system provided by the National Highway Traffic Safety Association. This organization's goal is to reduce the human toll and property damage that motor vehicle traffic inflicts on our society. The goal of this study was to use the data to determine which factors resulted in serious injuries and how we might be able to utilize these results to mitigate potential injuries in future automobile crashes. On to Step 2, data understanding. The data from the crash report sampling system is a sample of the car crash data from various crashes in which the police were contacted. These crashes involved any possible combination of vehicles, pedestrians, and cyclists within the United States. The data source for this mining study was provided in tabular form. Prior to the data cleaning process, the data set contained a total of 196 columns and 133,607 rows. The data set that we utilized in this analysis had a combination of 3 different variable categories provided by the National Highway Traffic Safety Association, including accident, person, and vehicle. So let's talk about those a little bit farther. The accident data could include anything from the number of persons in the vehicle, as well as the month, day, and time of day of the crash. Vehicle data could include vehicle year, make, model, body type, whether the accident was a rollover, and what kind of traffic control divide there was on the street where the accident occurred. The person data included the age, sex, and seating position, as well as any drug or alcohol involvement of the people that were in the vehicle. The software that we use to merge, clean, and model the data contained within these 3 data categories was 9. The majority of the values within this set were encoded, meaning a series of integer values were used in place of string values for each category. As part of the variable selection process, which Kelsey will describe farther in Step 3, the data preparation section, variables which held lower levels of influence in predicting the severity of automobile accidents were gradually filtered out from the data set, although there were also a few variables which were filtered out manually prior to the beginning of the variable section. So while we were looking through the data, our team identified that some of the variables were irrelevant to making predictions to an accident severity, such as customer ID values or VIN or vehicle identification numbers. As such, in order to avoid any noise which might have otherwise been generated by those variables, they were immediately removed from the data set. I will now pass it off to Kelsey for data preparation. Thank you.